Hello friends, today's question. A tennis ball is dropped on a horizontal smooth surface. It bounces back to its original position after hitting the surface. The force on the ball during the collision is proportional to the length of compression of the ball. Which of the following sketches represent the variation in its kinetic energy K with time t most appropriately? The figures are only illustrative and not to scale. So we have these four figures and we are supposed to find out a relationship between kinetic energy and time t for this condition. So let's first of all find out the relationship between the kinetic energy and time t. And it is given that the tennis ball is dropped from a certain height. We can say a ball is dropped on a surface. So under this condition, the initial velocity will be equal to 0 and acceleration gravity will be equal to g, and we say let its final velocity is given as v. So we can use the formula that v is equal to u plus at. So we get this as v is equal to gt. Therefore, the kinetic energy gained by the, you can say, ball rather, just before hitting the ground surface. Therefore, kinetic energy of the ball just before striking the surface. You can write this as k is equal to half mv square. We already know value of v, so we can write this as half m g square, and this equal to half m g square t square. Therefore, from here we can say our kinetic energy is directly proportional to t square. And this equation is in the form of a parabolic equation. Okay. This is in the formation of a parabola. Now, as this is the shape of the parabola, so we can say that the shape of the graph as the ball strikes the surface will be in the shape of a parabola. You can say shape of graph of kinetic energy versus time as the ball falls towards the surface will be a parabola. Okay. Now, as the ball hits the strikes the surface, you can say as the ball strikes the surface, kinetic energy is converted into elastic potential energy. Elastic potential energy. Secondly, now this elastic potential energy means the force acting on the ball is like resistive force, because it is given that the collision, the force on the ball in the collision is proportional to the length of compression of the ball. Because of that, we can say that therefore force acting on the ball is like a restoring force. This is more or less given. Restoring force proportional to the displacement, or we can say length, proportional to displacement or length. Now this is given to us. Now because of this restoring force, what is going to happen? The elastic potential energy is once again converted into kinetic energy. Okay. Thus, the elastic potential energy is converted into kinetic energy. And because of this, the ball will start to rise. Therefore, ball will start to rise. And once again, we can prove, thus kinetic energy is directly proportional to minus of t square. Okay. As now the acceleration will be negative of g. Okay. Because as a is equal to minus of g. Once again, this is the equation of parabola. Okay. Let me write it this way. This is also a representation of parabola. It means as the ball start to rise, that particular graph will be also in the shape of the parabola. Okay. Therefore, we can draw the graph like this. This is K. So it starts to go like this, then comes down, and once again rises, and then it will be a continuous process like this. And this is representation of figure B. This is the correct option. Okay. So we are going to get option number B is the correct one. Therefore, this completes the question. Thank you. There were mistake on my part. So you can say the kinetic energy for the second portion will be also equal to half mv square, and here velocity is once again equal to gt. So kinetic energy will be coming is equal to directly proportional to t square, so which is also a parabolic equation. Okay, I made a mistake in explaining the second part, so please excuse me. My apologies for that.